Okay, so we will start our discussion with data types. Data types are the very basic building blocks of the data structures we are going to discuss ahead. So we have various data types. First is byte, short, int, long, float, double. Then we have boolean and a char. Byte stores 1 byte of data. Short takes 2 bytes of data. Int take 4 bytes of data. Long takes 8 bytes of data. Float takes 4 bytes of data. Double again takes 8 bytes of data. Boolean will take 1 byte, but every time it will be using just 1 bit. This is usable amount. How it is like this is that in 1 byte there are some 8 bits, but the boolean variable will use just 1 bit, the last bit, as 0 or 1 to represent true or false. These 7 bits will never be used. So the boolean variable will take 1 byte but only use 1 bit of data. Character will take again 1 byte of data. Okay, so now we will discuss a bit about signed and unsigned type of variables. Signed and unsigned. What do we mean by signed is that, let's say there is a 4 bit of data we have. If this variable, or let's suppose the integer we have, if it is signed, then this particular bit, if it is having 1 or 0, this will represent our positive and negative number, the sign of the number. But if it is unsigned, that this bit will also just add the value to the unsigned integer. How signed bits are stored? Signed bits are not just stored as it is stored in 2's complement format. 2's complement format. Let's say I have to find 2's complement of some number. Let's say our number is 1010. So I have to store this number. This is 10, right? I have to store minus 10 in the variable. What I'll do is to take the ones complement, 0 1 0 1, and add 1 to it. I'll add 1 to it. So it will be 0, 1 will be it will be 1 1, and this again 1. So this is the 2's complement form, and this is how it is going to be stored in this particular register when it is a signed integer. So let's say we have 2 byte of data, 2 bits of data, just 2 bits. So the value will range from 2 power 0 to 2 power 1. So let's say we are having unsigned here, and we are having signed here. 2 power 1, 2 power 0. So let's say 2 power 0. Let's say we have a combination of 0 0, 0 1, 1 0, and 1 1. Okay, we'll hold, no issues. So yeah, let's continue. We were discussing that if we are having 2 bits of data, the bit will range from 2 power 1 to 2 power 0. Let's say we have a combination of 0 0 0 1 1 0 and 1 1 for an unsigned number. So this will give you a 0, this will give you a 1, this will give you a 2, and this will give you a 3. 0 being the minimum and 3 being the maximum. uh, let's say if it is signed integer, so 0 will represent a positive number. I mean, this will represent a positive, and this one will represent a negative. So this is 0, this is 1. This is a 2's complement form, so you have to reduce it to its normal form, then you will get that it's -2, and this is -1. So this is the minimum number that you're getting, and this is the maximum number that you're getting. Okay, so let's say if we can some deduce some type of formula from this. Let's say if we have bits for signed and unsigned. For 2 bits, we already saw our results. For 2 bits, sign is -2 to 1, unsigned is 0 to 3. For 4, it is -8 to 7. It is -8 to 7, and for unsigned, it will be 0 to 15. For 8 bits, it will be -128 to 127, and for the unsigned range, it will vary from 0 to 255. Yeah, 255. So let's say we'll reduce a formula for n. Take 2 minutes of your time and try to come up with a formula for this, for the minimum maximum range in the signed and unsigned type of variables for n bits. Not clicking to me. Okay, no issues. So it is minus of 2 raised to power n minus 1 to 2 raised to power n minus 1 minus 1. And for the unsigned, it is from 0 to 2 power n minus 1. So calculating these power of 2's is a bit difficult for a human mind. So what we usually do is to roughly estimate the 10 powers of 2 power, and then we can roughly say that this particular variable will store this much of amount. So let's say 1024 is roughly equals to 1000, and that is equals to 10 power 3, and this is equals to 2 power 10. So let's say we are having an integer variable. It stores 32 bits. So the maximum value will go up to 2 raised to power 32. That is somehow equivalent to 2 power 30. That is equivalent to 10 power 3 into 10 power 3 into 10 power 3. That is equal to 10 power 9. So we'll say that an integer variable will roughly store a 9-digit number. It is not the very exact range, but on a rough level, that if you just see a variable length, I mean the integer length, you should get to know that whether it will be whether it will get fit an integer variable or not, or should we go for the long. So let's say let's say we have some variable. We'll talk about the constraints we face in the online programming. So let's say we have a question of finding sum of an array. Finding sum of an array, wherein the constraints I'm having is that my number of variables can go from 1 to 10 power 4, and each of my variable will be from a range of 1 to 10 power 4 again. So the maximum sum in this case can be 10 power 8, right? 10 power 4 elements summed up 10 power 4 times. So the maximum sum in a case can go up to 10 power 8. So what I can say saying here is that an integer variable will be enough to store my sum. And let's say again we have the same problem but with a different constraint. I'll say that my number of elements in the array is 10 power 6, and let's say each of my number in the the element in the array will range from 1 to 10 power 8. So in a case the sum can maximum reach up to 10 power 14. So now an integer can store just a 9 length of variable, but it is going up to 10 power 14. So we will use long here. So just by seeing the constraints, you can actually roughly, not the particular estimate, but you can roughly estimate that which type of data type should you go for. Okay, so while we are discussing the online constraints, I will like to tell you something more over here. While doing online programming, your code should have a maximum of 10 power 8 iterations. This is the time limit you have. You can have maximum of 10 power 8 from most of the online competitive platforms. So let's say you have an n square algorithm, and your n is maximally reaching 10 power 2. It is ranging from 1 to 10 power 2. So if on this constraint you apply a n square approach, the maximum operations will be 10 power 4, that is under 10 power 8 range. So execute. This will execute. But let's say you have again a n square approach with your n ranging from 1 to 10 power 6. If you apply this n square approach on this constraint, the maximum reach you can have is 10 power 12. That is not in the range of 10 power 8 operations. So this will not execute. This will give you a TLE, time limit exceeded. So always while doing online programming, keep this in mind that the maximum number of your iteration should go 10 power 8. You should not exceed this limit. When we have discussed the time we can use, again we have the space constraints as well. The space constraint, you can use maximum of 10 past 7 bytes of memory. You cannot use more than that. So if you say that I have a array of 10 power 8 elements, that will never work. So now we will talk about the exponential representation. Exponential representation is generally represented by e. So what does it mean? If I say 1e6, that means 10 power 6. So if I say let's say take one more example, 3400, I need to show it in the form of e. What I'll say is 3e3 plus 4e2. This e means 10 power of this particular number that we are writing ahead of it, multiplied by the number we are writing before it. So in the general case, in e is double data type. So if you are saying that int I is equals to 1e6, this will give you an error. But if you want to use e in an integer type, you have to use it like this. You have to typecast it, int 1e6. So let's take some more examples. Let's say we have 400,005. We have 2.0003, and we have 6.00001. Try to deduce the exponential form of this. Take 2 minutes and try to come up with the exponential power for this exponential representation. Yes, correct. 4e5 plus 5 for 2.003. Worry about it, no issues. So I'll say 2 plus 3e minus 3, and for this I'll say plus um, 6 plus 1e minus 5. So now let's talk about modular arithmetic. Okay, got it. So we'll talk about modular arithmetic. That's a very small topic, but it really helps you out in some of the cases to get the correct answer. So while doing online competitive programming, you must have seen that in many of the questions you must have seen that if the number can be very big, so you are supposed to mod it by uh, that was a number of 1e7, right? Uh, just a second. Yeah, so it was a number 1e00007. So many a times you will see that you have to apply a mod of this number to the array to the answer to get the correct values. So how do you apply modular arithmetic? Let's say we have a plus b mod c. This is equal to a mod c plus b mod c, a total mod by c. Again for a minus b mod c, we will say a mod c minus b mod c, a total mod of c. For multiplication, again the same formula will work. A mod c my sorry multiplied by b mod c, a total mod of c. So now when we have discussed about the addition, subtraction and multiplication, the division does not allow modular arithmetic. Division does not supports modular arithmetic. So for the division, you have to go for inverse modulo. Inverse modulo. So this is your homework to study about what inverse modulo is. So now let's talk about operators. Okay, so the different type of operators we have is arithmetic, we have logical operators, we have relational operators, we have bitwise operators and assignment operators. Okay, so in arithmetic operators, that those very known plus, minus, divide, multiply, and modulo. Logical operators consist of logical and, logical or, and we have one more not operator, logical not. In the relation, we check out the relations greater than, less than, greater than equals to, less than equals to, double equals to, and not equals to. Bitwise, we are having and, or, that's a XOR, negate, left shift, and right shift. Assignment operators are like size of, question colon, and etc. This list is very big. Okay, so now we will talk about the bitwise operators because these are the operators that are very less known to the people. And we are going to solve some questions on the bit manipulations going ahead. So let's say we are having a and a B. So let's say what will be the value of A and B. We'll take the combinations over here: 0, 0, 0, 1, 1, 0, and 1, 1. Can you tell me the value of A and B for 0, 0? Okay, cool. Proceeding ahead, it will also be 0, it will also be 0, and this will be 1. A or B. This will give me 0 here and 1 on the every other place. Let's talk about A, XOR B. So what XOR do is that if both of the bits are same, I mean to say that if both of the bits are 0 and 0 or both of the bits are 1 and 1, it will produce an unset bit. It will produce an unset bit for the similar bits and it will produce a set bit for the different bits. So let's say how negate of A will work. Negate of A is just an opposite. So if you'll give 0, it will produce 1, and if you'll give 1, it will produce 0. So let's talk about some of the properties of bitwise operators. I'll create a new whiteboard. Okay, so it is like, can you tell me the answer of A and A? Take some example and try to deduce the formula for this. Let's say A and A is 1. Let's say I have 1, 0, 1. This is my number. I am creating an AND with 1, 0, 1. What will be my result? 1, 0, 1, right? It is equals to A. A and A is equals to A. Are you clear with this? Okay, cool. So now let's say A and 0. What will be this equal to? Okay, cool. It is 0. Let's talk about the properties for OR. A or 0. What will this be equal to? Okay, cool. A. Now something interesting. A or 1. What will be the answer for this? Try to take a odd number and try to take a even number. In both of the cases, you will get a different answer for A or 1. Let's say take an example of 101 and 100. So this is an odd number, this is an even number. Try to operate this or 1 on these two numbers and try to reduce a formula. A in case of odd, correct. A if it is odd, and in case of even, seems like Zor is no. Okay, let's take an example over here. Let's take this 100 only. So 100 or with 1. We are creating an OR with 1. So this bit will produce always 1, 0, 1. This is literally A plus 1. So take any of the even number when, okay, so every of the even number will end with 0, and every of the odd number will end with 1. The reason being, in the bit representation, the first bit always denotes a value 1. It goes like 1, 2, 4, 8, 16. So this always represent ones. So every time there is a odd number, it will be ending with 1 in the last bit, and every time there is an even number, it will be ending with 0 in the last bit. So now when you will OR 0 with 1, it will always produce 1, and that will add 1 to the value that we are having as an operand. So it will always have A plus 1 as the result. So now, bitwise operators are always associative and commutative. What do I mean by this? I mean to say that A or B or C is equals to A or C or B, or I can say that it is also equals to B or A or C. Another way I can say is that A or B or C is equals to A or B or C, or I can say is that I can say that A or C or B. Every of the result will be equivalent. So let's talk about the properties of XOR now. Try to deduce a formula for A XOR 0. Let's take some example. Let's say we are having 1 0 1 1. I'm creating a XOR with zeros. So now for every of the 1 and this being 0, what will be the result? Cool, cool. For 0 0, sorry, just a second, I'm confused. Sorry, yeah, so it will be 0, right? And this will again be 1. So A XOR 0 always remains A. Now A XOR A, what will be the result for this? Let's again take some example. I'm XORing this number with this number itself. So all of the bits will be similar, right? So it will produce out the 0. So A XOR 0 is always equals to A, and A XOR A is always equals to 0. So now let's say when we know that A XOR A is equals to 0, and I say that A XOR A XOR B, what will be the value of this? A XOR A will give you 0, 0 XOR B, 0 XOR B is equals to the number itself, B. So we can say that any number if repeated twice, XORed with any number, this will give you this number. Yeah, you're correct. Okay, so let's talk about the left shift and right shift operators a bit. Let's talk about the right shift operator first. The right shift operator. What right shift operator do is to literally shift every of the bit to the right part. So let's say I'm having a with some number, let's say 0, 0, 1, um, 0, 1, 0, 0, 0. A right shift by one position. This is 0, 0, 0, 1, 0, 1, 0, 0. So this number is 40, right? Just a second. 2, 4, 8, 16, and 32. Yes, this is 40. Can you let me know what will be the results of A double shift, A shifted by 2 times and A shifted by 3 times? Okay, I'll continue. 0, 0, 0, 0, 1, 0, 1, 0. Maybe you have done the left shift. We are talking about right shift. Oh, okay, good. So we are shifting to the right position, right positions. 0, 0, 0, 0, 1, 0, 1. So let's note down what these numbers are. This is 16 plus 4, that's 20. This is 8 plus 2, that's 10. And this is 4 plus 1, that's 5. So can you see a pattern over here? That every time it is divided by 2. So every time you're right shifting a particular number by one bit position, it gets divided by 2. Every time you're right shifting a particular number by 2 bits, it is getting divided by 4. Same for 3, it will get divided by 8. So in a general, I can say that if I right shift A by I positions, the equivalent result will be A by 2 power I. Are you able to get this? Okay, cool. So we'll talk about the left shift now. Let's talk about left shift. So just opposite to right shift, what left shift will do is to shift it to the left positions. Let's say again I have a A 0, 0, 0, 1, 0, 0, 1, 0. A multiplied by 2. No, we are getting it divided, right? It will not be multiplied. Multiply is in the case of left shift. So see, we are having a number 40 here. It is after right shifting it. Yeah, for left shift it will be 2 multiplied by them. Okay, so yeah. For left shift it will be this case. So let's say it is 18. So for A left shifted by 1, it will go to 36, and A left shifted by 2 will go to 72. I'll just write down the bit representation, and for A2 it is 0, 0, 1, 0, 0, 0. And yes, as you said that for A left shifted by I, it will be equivalent to A multiplied by 2 power I. You were correct in this. Okay, so while proceeding further, let's say we'll solve a question. Let's say uh, just a second. I'll reconnect my internet. Yeah, am I audible now? Am I audible now? Please try to reconnect your internet once then. Acha, he's not able to. Yeah, hi. Are you able to hear me? Okay, cool. So we'll go forward. Let's say I have given you a number, let's say n, and I have given you a bit position I. What I want you to do is to check that whether the ith. Are you able to hear me? Okay, cool. So let's say I've given you given a number n and a bit position I. I want you to check that whether the ith bit position is set or unset. So for example, I give you 10. So the binary representation will be like 1010. I want you to check that whether this particular bit is set or unset. How will you proceed for this particular question? Take 2 minutes of time and think about it, or else we'll discuss the solution. We'll go and do negation of particular bit. How will you go to that particular bit? How will you go to that particular bit? Okay, cool. We'll discuss the solution. So let's say if I add this number but with this particular number, where one is on the bit position that I want to check, and else everything is zero. And if I take a AND, there can be two possible values at this position, right? One or zero. So for zero, our total result will become zero, right? These will always be zero because as it is zero, and no matter what the values are here, we are taking an AND. So these values will be zero. For this value being zero and this value being one, this will produce a zero. And for say that if we are having 1 in this bit position, this will be 1, this will again be 1, and it will be producing some non-zero number. So this is a zero number and this is some non-zero number. So what my problem boils down is to create this number. What I'll say is just return a value of n and 1 left shifted by I positions. If it is equals to 0 or if it is not equals to 0. That's what all we need to do. You got this point? You got this formula? This one left shift I is generating this number. Okay, cool. So this is a check bit function that will directly check that a particular bit in a particular number is set or is it unset. So we are going to use this check bit function in lot many questions that we are going to solve forward. So please take a better note of this. So proceeding further, uh, let's say I have given you x and I have given you y. So what you're supposed to generate a number with set positions and x and y. What I'm trying to say is, let's say my x is 4 and my y is 6. So these will be the bed position 1, 2, 3, 4, 5, 6, 7. For this particular case, what I am saying is that 6 and 4, these will be set and else everything will be unset. How will you proceed to this problem? Take 2 minutes of time and think about it. So for 3 and 5, it will be like for the fifth position and third position it will be set, and for others it should be unset. You have to generate this number. Okay, cool, no issues. So we are having a bit position 1 set at 4, bit position 6 as a set bit position. So what if I say that 1 left shifted by 4, this will give me this bit as set, and I'll take a OR of this particular number with 1 left shift by 6. So this particular will give me a bed position set at this position, and this will give me a bed position set at this particular position, and I'll take a OR. So we will be able to generate this number. Same as in goes for this particular solution. 1 left shift by 3, 1 left shift by 5. So in general for x and y, I can say that return for the in the function return 1 left shift by x and 1 left shift by y. You got this? Got it. Cool. Proceeding further, let's say, okay, one homework question before proceeding further. Let's say in this question, you are again given x and y. Let's say it is 2 and 3. So what you are supposed to do is x number of set bits followed by y number of unset bits. So the number in this case should be 1, 1, 000. So for x to be 3 and y to be 5, it should be 1, 1, 1, 5 zeros. This is your homework question. That you have to generate a number such that it has x set positions followed by y unset positions. Try to solve it out, or else we'll discuss it in the next session. You got the question, right? Okay, cool. So now, let's say we are given a number and we are supposed to count the number of set bits it is having. So let's say you're given a number n. Let's say we are taking 12 in this case. So 12 will be like 1, 8 and 4 and 0 and 0. So the answer should be 2, that there are two set bit positions. For 15, it is 1, 1, 1, 1. The answer should be 4. The number of set positions we have in a particular number. We already looked out to how to check a particular bit is set or unset. Can you try to reach out this problem now? Okay, you're given a number n. Let's say you're given number 12. The binary representation will be 1100. You're supposed to count how many of set bits are there. So there are 1 and 2. So the answer will be 2, that there are two set bit positions. For number 15, the representation is 1111. You're supposed to find the number of set bit positions. These are 1, 2, 3, and 4. So the answer is 4. For 10, the binary representation is 1010. There are two set bit positions. You got the question? Okay. So we have already discussed that checking out a particular bit, how can we check that if it is a set or unset? Can you build up thinking in that way only, that how can we find out that every of the bit is set or unset? We have to count the number of set bits. Can we use that particular formula again? Ending with 1100. Um, and operation with same number. And operation with same number, let's say we have 1100 and I'm saying and with the same number, it will just produce me out the same number. A and A is equals to A, right? So how will you able to count the number of set bits in a year? Okay, we'll discuss the solution, no issues. So let's say we have this n count bits with an integer variable n. We have to count the number of set bits in this particular n. So let's say my initial count is 0. What I'll say is that while my n is not equals to 0, if n and 1 is equals to 1, I'll say count plus plus, and then I'll say n is equals to n, right shift by one position. I'll close my while loop and I'll close my function. I'll just say return count. So let's deduce that how this particular function is working. So let's take 1100 as our example. In the first iteration, it will come and check that whether my number is equals to 0 or not. So no, it is not equals to 0. It will come inside and will check and with 1. Or rather than saying that is equals to 1, I should say that if it is not equals to 0, this condition is wrong. Okay, so I'm saying and with 1, um, or I can just directly say that for this particular, rather than saying this particular condition, I can just say if we'll use that check bit function, check bit of n at position 1. Every time for my first position, I'll check. So every time I'll encounter a set bit position, I'll say count plus plus. And for after every iteration, so let's say my number was 1100, my number will become 110. For the after next iteration, it will become 11. After that, it will become, and it will become 0. As soon as it becomes 0, this while loop condition will false out, and after that we will return the count. You got this? Okay, so we'll proceed further. This will be the last question for today. Let's say we are having an array. Given an array, every of the number is repeated twice except one number. What I'm trying to say is that we are having a area like this: 1 2 2 3 1 4 3 5 5. In this particular example, 1 is repeating twice, 2 is repeating twice, 3 is repeating twice, 5 is repeating twice. 4 is the only number that is not repeated. Given an array such that every of the element is repeated twice and there is one exception to this, find me out the non-repeated element. So the very first solution, brute force solution we can have will be an n square approach, that I'll pick up one, and for the entire array I will look up if there is one or not. Yes, I got the one. Then I'll take the next particular number. Then I'll take the next particular number, and so on. As soon as I get a number that is not repeated, I'll return that particular number. So this will be an n square approach, as I will be having two for loops. For every of the element, I am checking for every of the other element that is there. Let's try to solve this particular question in O of n using a XOR operator. So we already studied that A XOR A is 0 and A XOR B is equals to B. So let's say what will be the answer of A XOR A XOR B XOR C XOR C. C XOR C will cancel out each other, A XOR A will cancel out each other, and B will remain. This is exactly what we are supposed to do in this particular question. What all I'll do is, I'll take a XOR of every number. 1 XOR 2, XOR 2, XOR 3, XOR 1, XOR 4, XOR 3, XOR 5, XOR 5. So in this case, 5 and 5 will cancel out each other, 1 and 1 will cancel out each other, 2 and 2 will cancel out each other, 3 and 3 will cancel out each other, and the only number remaining will be 4. This will be automatically generated to us. So what all I'm supposed to do is, I'm having an int result that is 0. So I'll write out a loop over here, and in the loop what I'll do is to take a for loop for int I from 0 to array.length, and I'll take XOR of every of the number I'm taking in. So at last what I will be left with will be the number that is not repeated. Are you clear with this answer? I mean the solution? Okay, once again, no issues. Okay, no issues. So let's say this was our example, let's say. So here 1 is repeated twice, 2 is repeated twice, 4 is repeated twice, and 3 is the number that we have to generate. So for the properties we have A's or A is equals to 0, right? We were having A's or 0 is equals to A. We were having A's or B as equals to B. These were the properties that we read. So let's say I'm taking a particular condition like this into the consideration. A's or A, Zor B, Zor C, Zor C. So A's or A will produce 0, C's or C will also produce 0, and B will remain as it is. Now 0 Zor B is B, Zor with 0, this will remain B. You got this point? And yeah, these Zors are associative and commutative, so I can take anyone into the consideration in any order. So what I'll do is, for every of the element in array, for every element in array, I'll just take XOR of all the elements. I'll say 1 XOR 2, XOR 2, XOR 3, XOR 1, XOR 4, XOR 4. So 1 XOR 1 will produce 0, 2 XOR 2 will produce 0, 4 XOR 4 will produce 0, and 3 will remain as it is. Again taking, while the solution is going, this will produce out to the 0. This will give me out the non-repeated element. Got this point? Okay, cool. So if you have any question from the throughout of the session, please ask, or else we'll bind up for now. Okay, cool. Thank you.